There's a secret hidden in the physics of light-speed travel that would make even the bravest astronaut refuse the mission. Every grain of dust becomes a nuclear weapon. Every hydrogen atom becomes a high-powered rifle bullet. The universe has built-in defenses against high-speed travelers, and today we're going to explore why reaching the cosmic speed limit would be the last thing you ever do. And here's a question for you. If you could travel 1 light year per second, where in the universe would you go? Let me know in the comments. I will pin the most creative answer. Now let's begin. The dream of light-speed travel has captivated humanity since we first understood what light actually is. Science fiction has painted beautiful pictures of starships gracefully gliding between worlds at incredible velocities, their crews safely protected behind energy shields or advanced hull materials. But the reality of approaching light speed is far more terrifying than any science fiction writer has dared to imagine. The universe becomes a cosmic minefield where every atom of hydrogen becomes a deadly projectile. At light speed, your spacecraft would be moving at 299,792,458 meters per second. To put this in perspective, you could circle Earth's equator 7.5 times in a single second. But here's where physics becomes your enemy. At these velocities, even the most harmless objects in space transform into weapons of mass destruction. A single hydrogen atom, the most common element in the universe, would hit your spacecraft with the energy of a high-powered rifle bullet. The interstellar medium, that seemingly empty space between stars, isn't actually empty at all. It contains roughly 1 hydrogen atom per cubic centimeter, along with traces of heavier elements, cosmic dust particles, and various molecules. At normal spacecraft velocities, this thin soup of matter poses no threat. But at light speed, this cosmic fog becomes a continuous barrage of relativistic projectiles, each one carrying enough energy to punch through any material we know how to make. Let's do some terrifying math. At 99% of light speed, a proton, just a single hydrogen nucleus, would strike your spacecraft with an energy of about 7 billion electron volts. That's roughly 1,400 times more energetic than the protons in the Large Hadron Collider, the most powerful particle accelerator ever built. Your spacecraft wouldn't just be flying through space, it would be flying through a continuous particle beam weapon that makes our most advanced physics experiments look gentle. The cosmic ray environment becomes exponentially more dangerous as you approach light speed. Cosmic rays are high-energy particles that constantly bombard everything in space, but they're normally manageable with proper shielding. However, due to relativistic effects, as your spacecraft approaches light speed, the cosmic ray background would appear dramatically blue-shifted and intensified from your perspective. What starts as manageable background radiation becomes a lethal torrent of high-energy particles. But the hydrogen atoms and cosmic rays are just the beginning of your problems. Space also contains dust grains, tiny particles of rock, ice, and organic compounds left over from stellar formation and planetary collisions. These microscopic bullets, typically just micrometers across, would impact your light-speed spacecraft with the force of artillery shells. A dust grain the size of a grain of sand would hit with the explosive power of several tons of TNT. Before we dive deeper into the physics of cosmic destruction, I want you to understand that this journey we're taking together, exploring the universe's most extreme conditions, is only possible because of curious minds like yours. Hit that subscribe button and ring the notification bell, because the cosmic realities we're uncovering reveal not just the dangers of high-speed travel, but the incredible ingenuity required to explore our universe safely. The concept of time dilation adds another layer of horror to light-speed travel. As you approach the speed of light, time slows down dramatically for you relative to the rest of the universe. This means that while you might experience only minutes or hours of this cosmic bombardment, the outside universe would age by years or decades. You'd be trapped in a relativistic nightmare where every second of your experience corresponds to months of real time, during which your spacecraft continues to be pummeled by the interstellar medium. The energy requirements for light-speed travel reveal another fundamental problem. According to Einstein's mass-energy equivalence, as you approach light speed, your spacecraft's relativistic mass approaches infinity. This means that accelerating even a tiny spacecraft to light speed would require infinite energy, more energy than exists in the entire observable universe. The universe has built a mathematical wall that prevents anything with mass from reaching the cosmic speed limit. Even if we could somehow solve the energy problem, the structural integrity of any spacecraft would fail long before reaching light speed. The continuous bombardment by interstellar particles would gradually erode any material, no matter how advanced. Imagine trying to build a car that could drive through a continuous sandblaster, except the sand is moving at relativistic speeds, and each grain hits with the force of a bullet. No material science breakthrough could create a hull capable of withstanding such punishment. The radiation environment at near-light speeds becomes so intense that it would cook any biological organism in seconds. The blue-shifted cosmic microwave background radiation, normally a gentle 3-degree whisper from the Big Bang, would appear as intense gamma radiation from the spacecraft's perspective. The crew wouldn't just face death from particle impacts, they'd be simultaneously roasted by the universe's own background radiation, transformed into a cosmic oven by their extreme velocity. Magnetic fields, which normally provide some protection against charged particles, become useless at light speed. The magnetic field lines themselves would be compressed and distorted by relativistic effects, creating chaotic field configurations that might actually focus dangerous particles toward the spacecraft rather than deflecting them away. The very systems designed to protect the crew would become part of the problem. The psychological horror of light-speed travel extends beyond the physical dangers. Due to relativistic effects, the view outside your spacecraft would be dramatically distorted. The stars ahead would be blue-shifted into invisible ultraviolet and X-ray wavelengths, while the stars behind would be red-shifted into infrared invisibility. You'd be flying blind through a universe that appears almost completely dark, with only a narrow ring of visible light around the edges of your field of view. Navigation becomes impossible at light speed because the very act of observing your surroundings changes what you see. The Doppler effect would shift all electromagnetic radiation to different wavelengths, making it impossible to use normal stellar navigation techniques. Radio communications with Earth would be similarly affected, with signals becoming so red-shifted or blue-shifted that they'd be unrecognizable. You'd be truly alone in a relativistic bubble, cut off from all normal means of communication and navigation. The concept of stopping presents its own set of insurmountable challenges. If you somehow survive the acceleration to light speed and the journey itself, how would you decelerate at your destination? The same physics that makes acceleration deadly also applies to deceleration. You'd need to shed enormous amounts of kinetic energy while continuing to be bombarded by particles that appear to be moving at light speed relative to your decelerating reference frame. The phenomenon of length contraction adds another nightmarish dimension to light-speed travel. As your spacecraft approaches the cosmic speed limit, distances in the direction of travel would appear to shrink dramatically from your perspective. A journey that should take years would appear to compress into a much shorter distance, but this isn't the blessing it might seem. The compressed space ahead of you becomes a concentrated death zone where all the hazardous particles and radiation that would normally be spread across light years are now packed into a much smaller region. From the perspective of someone watching your light-speed journey from Earth, your spacecraft would appear to flatten like a pancake in the direction of travel. This isn't just a visual illusion, it's a real physical effect predicted by Einstein's special relativity. Your three-dimensional spacecraft would be compressed into something resembling a two-dimensional object, with all the structural stresses and material failures that such extreme deformation would entail. The electromagnetic radiation from your spacecraft's own systems would become a weapon against you. Any light emitted from your ship, whether from engines, life support systems, or even simple LED displays, would be Doppler shifted to extreme frequencies. Light emitted forward would be blue shifted into deadly gamma rays, while light emitted backward would be red shifted into useless, long wavelength radiation. Your own technology would become a source of lethal radiation. Speaking of the incredible challenges of space travel and the realistic limits of human exploration, if you're curious about how far we could actually travel using more reasonable velocities that wouldn't instantly kill us, you should check out my video, How Far Could Humans Travel Through Space in One Lifetime? It explores the fascinating physics of achievable interstellar travel and shows that even without light speed, the cosmos offers incredible destinations within human reach. The link is in the description and on the card above. The concept of simultaneity breaks down completely at light speed, creating paradoxes that would make navigation and mission planning impossible. Events that appear simultaneous to you would occur at different times for observers in other reference frames. This means that any attempt to coordinate with Earth or other spacecraft would be futile. You'd be operating in a completely different temporal framework where cause and effect relationships become scrambled. Particle physics experiments have given us glimpses of what happens when matter approaches light speed, and the results are terrifying when scaled up to spacecraft-sized objects. In particle accelerators, we routinely accelerate subatomic particles to 99.9% of light speed, and we observe how they interact with matter at these velocities. The energy releases are so enormous that they can create new particles from pure energy, following Einstein's famous equation E equals mc squared. The synchrotron radiation produced by charged particles moving at near-light speeds would turn your spacecraft into a cosmic lighthouse, broadcasting your location across the galaxy while simultaneously draining energy from your ship's systems. Any charged particles in your spacecraft, and there would be many from cosmic ray impacts and your own electronics, would spiral around magnetic field lines and emit intense electromagnetic radiation, creating a continuous energy drain that would eventually shut down all your systems. The concept of the event horizon takes on new meaning at light speed. Just as black holes have event horizons beyond which no information can escape, light-speed travel creates its own information barriers. You couldn't send messages back to Earth because any electromagnetic signal you transmitted would be so red-shifted that it would become undetectable. You'd cross an informational event horizon, becoming forever cut off from the rest of humanity. The quantum mechanical effects at light speed introduce uncertainties that make survival impossible to calculate. Heisenberg's uncertainty principle states that you cannot simultaneously know both the exact position and momentum of a particle. At light speeds, where momentum becomes enormous, the uncertainty in position becomes correspondingly large. This means that the very atoms making up your spacecraft would become quantum mechanically fuzzy, with their positions uncertain enough to potentially cause the entire structure to lose coherence. The vacuum of space itself becomes hostile at light speed due to quantum field effects. What we call empty space is actually filled with virtual particles that constantly pop into existence and annihilate each other. At light speed, these quantum fluctuations would appear dramatically enhanced due to relativistic effects, potentially creating a resistance force that would slow your spacecraft while simultaneously bombarding it with virtual particle interactions. Temperature regulation becomes impossible at light speed due to the extreme Doppler shifting of thermal radiation. Your spacecraft's heat radiators, designed to emit infrared radiation to cool the ship, would have their emissions blue shifted to higher frequencies, making them less efficient at heat removal. Meanwhile, any external heat sources would appear blue shifted to dangerous frequencies. You'd be trapped in a thermal nightmare where normal cooling systems fail while external radiation sources become more intense. The biological effects of light-speed travel extend far beyond simple radiation exposure. The human body relies on countless chemical reactions that occur at specific rates determined by molecular motion and quantum mechanics. At light speed, relativistic effects would alter the fundamental rates of these biochemical processes. Your metabolism, neural activity, and cellular repair mechanisms would all be affected in unpredictable ways, potentially causing immediate biological system failures. The concept of mass-energy equivalence becomes personally relevant at light speed. As your velocity approaches the cosmic speed limit, your relativistic mass increases dramatically. This doesn't just affect the energy required for acceleration, it affects every aspect of your existence. Your increased mass would alter gravitational effects, change how you interact with electromagnetic fields, and potentially affect the fundamental forces holding your atoms together. Navigation by stellar positions becomes impossible because the apparent positions of stars would be dramatically altered by relativistic aberration. Stars directly ahead would appear to cluster into a bright ring around the forward direction, while stars behind would disappear entirely due to extreme redshifting. The familiar constellations that have guided human navigation for millennia would be unrecognizable, leaving you lost in a relativistic funhouse where the very geometry of space appears distorted. The structural engineering challenges of light-speed spacecraft design reveal fundamental impossibilities. Any material strong enough to withstand the particle bombardment would need to be denser than neutron star material, matter so dense that a teaspoon would weigh as much as a mountain. But such dense materials would create their own gravitational fields strong enough to affect the spacecraft's trajectory and potentially collapse into a black hole. The concept of fuel becomes meaningless at light speed because any reaction mass ejected from your spacecraft would carry away enormous amounts of energy due to its relativistic mass. Traditional rocket propulsion becomes not just inefficient but actively counterproductive as the energy cost of accelerating fuel to ejection velocity approaches infinity. You'd need a propulsion system that operates on principles we haven't discovered yet. Communication delays take on existential significance at light speed. Any message sent to Earth would be so redshifted that it would take enormous amounts of energy to transmit and detect. Meanwhile, any messages from Earth would be blue shifted to such high frequencies that they derive as deadly gamma radiation rather than useful information. You'd be forever cut off from human civilization, unable to share your discoveries or call for help. The psychological impact of relativistic effects would be devastating even if you somehow survived the physical challenges. Time dilation means that while you experience minutes or hours of this cosmic nightmare, years or decades pass on Earth. Everyone you've ever known would age and die while you're trapped in your relativistic prison. You'd return to find a world that has moved on without you, assuming you could return at all. The concept of identity becomes questionable at light speed due to the extreme physical and temporal distortions. The atoms in your body would be subject to such intense forces and relativistic effects that the very concept of you as a coherent biological entity becomes meaningless. You wouldn't just be traveling at light speed, you'd be transformed into something that might no longer qualify as human. The phenomenon of Cherenkov radiation would turn your spacecraft into a deadly light show as particles moving faster than the local speed of light in any material aboard your ship would emit intense blue light. This isn't just a pretty glow, it's a sign that your spacecraft structure is being continuously bombarded by particles with enough energy to exceed light speed in matter. Every surface, every component, every piece of equipment would be glowing with this eerie blue radiance, indicating ongoing radiation damage at the atomic level. The magnetic field interactions at light speed create scenarios that defy our normal understanding of electromagnetism. Earth's magnetic field, which normally provides gentle protection against solar wind, would appear as an impenetrable barrier to a light-speed spacecraft. The field lines would be so compressed and intensified from your relativistic perspective that approaching any magnetized object, including planets, stars, or even other spacecraft, would be like flying into a magnetic wall that could tear your ship apart through electromagnetic forces. Gravitational effects become exponentially more complex at light speed due to the equivalence of mass and energy. Your spacecraft's enormous kinetic energy would create gravitational effects equivalent to having the mass of a small planet. This means you wouldn't just be traveling through space, you'd be warping space-time around you, creating gravitational waves and potentially affecting the orbits of any objects you pass near. You'd become a gravitational anomaly, disrupting the cosmic order wherever you travel. The concept of simultaneity collapse creates paradoxes that would make any coordinated mission impossible. If you're traveling at light speed toward a destination star, events that appear to happen now at that star actually occurred years ago from Earth's perspective, but they appear to be happening in your future from your relativistic reference frame. This temporal scrambling means that any attempt to plan your arrival or coordinate with other missions becomes logically impossible. Quantum entanglement effects, which normally operate instantaneously across any distance, would become distorted by your extreme velocity. The quantum correlations that connect entangled particles might be stretched or broken by relativistic effects, cutting you off from any quantum communication systems that future technology might develop. You'd be isolated not just from classical communication, but potentially from quantum information networks as well. The cosmic microwave background radiation, that gentle 3-degree whisper from the Big Bang, would become a furnace of death from your perspective. This ancient light, normally invisible and harmless, would be blue-shifted into intense gamma radiation that would cook you alive. The universe's own baby picture would become a weapon against anyone moving fast enough to see it in its true, deadly form. You'd be killed by the afterglow of creation itself. Stellar aberration would create a visual nightmare where the entire universe appears to collapse into a narrow cone ahead of your spacecraft. Stars that should be spread across the sky would appear compressed into a bright ring, while everything behind you would vanish into infrared invisibility. You'd be flying through a universe that appears to have only one dimension, with all the navigation and psychological challenges that such distorted perception would create. The concept of rest mass becomes meaningless at light speed because your relativistic mass approaches infinity while your rest mass remains constant. This creates a fundamental paradox in physics. You'd have infinite mass from the perspective of external observers while still having finite mass from your own perspective. This mathematical impossibility is one of the universe's ways of saying that light-speed travel for massive objects simply cannot occur. Particle creation from vacuum fluctuations would accelerate dramatically in the intense electromagnetic fields generated by your light-speed motion. The Schwinger effect, where virtual particles become real in sufficiently strong electric fields, would begin operating continuously around your spacecraft. You'd be surrounded by a cloud of newly created particles, each one adding to the chaos and energy drain of your impossible journey. The Unruh effect predicts that accelerating observers see thermal radiation in what appears to be empty vacuum to non-accelerating observers. At the accelerations required to reach light speed, this effect would make empty space appear to be filled with hot thermal radiation, you'd be flying through what appears to be a furnace, even in the coldest, emptiest regions of interstellar space. The vacuum itself would become your enemy. Tidal forces from your own gravitational field would begin tearing your spacecraft apart as your relativistic mass increases. Just as the Moon creates tides on Earth through gravitational gradients, your enormously massive light-speed spacecraft would create tidal forces within itself. Different parts of your ship would experience slightly different gravitational fields, creating stresses that would rip the structure apart from within. The concept of causality breaks down completely at light speed, creating logical paradoxes that make the journey meaningless. Information about your departure from Earth would travel at the same speed as your spacecraft, meaning that from certain reference frames you could arrive at your destination before information about your departure reaches observers there. You'd become a causality violation, arriving before you left. Hawking radiation effects would begin manifesting around any extremely dense components of your spacecraft. As your relativistic mass increases, regions of your ship might approach the density required for black hole formation. These proto-black holes would begin emitting Hawking radiation, slowly evaporating while simultaneously growing through accretion of surrounding matter. Your spacecraft could literally begin eating itself through quantum mechanical processes. The electromagnetic pulse generated by your passage would be devastating to any electronic systems in your path. Moving at light speed through the galaxy's magnetic field would generate electromagnetic effects similar to a massive solar flare or nuclear electromagnetic pulse. Any planets, space stations, or other spacecraft in your vicinity would have their electronics fried by the electromagnetic wake of your passage. Frame dragging effects would cause space-time itself to rotate around your rapidly moving, massive spacecraft. This gravitomagnetic effect, normally only significant near rotating black holes, would begin manifesting around your light-speed vessel. The very fabric of space-time would be twisted into spirals by your passage, creating gravitational anomalies that could persist long after you've moved on. The concept of proper time becomes meaningless when your journey time approaches zero, while coordinate time approaches infinity. From your perspective, the journey might seem instantaneous, but from the universe's perspective, it takes the normal amount of time for light to travel the distance. This temporal paradox means that you'd experience arriving before you experience traveling, creating logical impossibilities that break the normal flow of cause and effect. Vacuum decay scenarios become possible when the enormous energies involved in light-speed travel interact with quantum fields. Some theories suggest that our universe exists in a metastable vacuum state that could be triggered into a lower energy state by sufficiently extreme conditions. Your light-speed spacecraft might accidentally trigger a vacuum decay event that would propagate outward at light speed, potentially destroying the universe as we know it. The concept of information preservation becomes problematic when the extreme conditions of light-speed travel might destroy the quantum information that defines your identity. Quantum mechanics suggests that information cannot be destroyed, but the intense radiation, particle bombardment, and relativistic effects might scramble the quantum states that make you you beyond any possibility of recovery. Spontaneous particle pair production would occur continuously in the intense electromagnetic fields surrounding your spacecraft. The energy density would be so high that virtual particle pairs would constantly become real, creating a cloud of matter and antimatter around your ship. These particles would immediately annihilate, releasing gamma radiation and adding to the already lethal radiation environment. The concept of measurement becomes impossible at light speed because any attempt to observe your surroundings would require interaction with photons that are moving at the same speed as your spacecraft. You couldn't see where you're going, measure your velocity, or determine your position because the very act of observation requires information transfer at light speed, which becomes impossible when you're already moving at that speed. The phenomenon of relativistic plasma formation would turn the space immediately around your spacecraft into a hellish soup of ionized particles. As your ship plows through the interstellar medium at light speed, the kinetic energy of impact would be so enormous that it would strip electrons from atoms, creating a plasma wake behind your vessel. This plasma would be hotter than the core of the Sun and would continue to emit deadly radiation long after your passage, leaving a trail of destruction across the galaxy. Quantum chromodynamics effects would begin manifesting at the subatomic level as the enormous energies involved in light-speed travel approach the scales where the strong nuclear force operates. The quarks and gluons that make up the protons and neutrons in your spacecraft's atoms would begin behaving in exotic ways, potentially leading to the formation of strange matter or quark-gluon plasma. Your ship wouldn't just be destroyed, it would be transformed into exotic states of matter that don't normally exist outside of neutron stars. The concept of coordinate systems breaks down completely at light speed because there's no valid reference frame for an object moving at the cosmic speed limit. Einstein's special relativity forbids the existence of a reference frame moving at light speed, which means that from a physics standpoint, you simply cannot exist as a massive object at that velocity. The mathematics of space-time itself conspires to prevent your journey from being possible. Bremsstrahlung. Radiation would be continuously generated as charged particles in your spacecraft are decelerated by interactions with the interstellar medium. This braking radiation would be emitted across the entire electromagnetic spectrum, from radio waves to gamma rays, creating a continuous energy drain on your ship's systems while simultaneously announcing your presence to any civilization within light years of your path. You'd be a cosmic beacon of destruction, visible across vast distances. The concept of entropy production would accelerate dramatically during light-speed travel. The second law of thermodynamics states that entropy always increases in isolated systems, but at light speed, the rate of entropy production would become enormous. Every interaction with interstellar particles, every emission of radiation, every quantum process would contribute to a rapid increase in disorder that would quickly render your spacecraft systems inoperable. Vacuum polarization effects would create virtual particle pairs in the intense electromagnetic fields generated by your light-speed motion. These virtual particles would briefly separate before annihilating, but during their short existence, they would contribute to the electromagnetic chaos surrounding your spacecraft. The vacuum itself would become electrically polarized, creating additional resistance to your motion and contributing to the overall energy drain. The concept of simultaneity surfaces becomes impossible to define when you're moving at light speed. In special relativity, events that are simultaneous in one reference frame occur at different times in other reference frames, but at light speed, this effect becomes so extreme that the very concept of now loses all meaning. You'd exist in a temporal limbo where past, present, and future become indistinguishable. Gravitational redshift effects would become extreme as your enormous relativistic mass creates significant gravitational fields around your spacecraft. Light trying to escape from near your ship would lose energy climbing out of your gravitational well, becoming redshifted to longer wavelengths. This means that any signals you try to transmit would be weakened and distorted by your own gravity, making communication even more impossible than relativistic effects alone would suggest. The concept of geodesics, the paths that objects follow through curved space-time, becomes meaningless at light speed because massive objects cannot follow light-like geodesics. You'd be trying to follow a path through space-time that's reserved for massless particles like photons. It's like trying to drive a car on a road that only exists for things that have no substance, a fundamental impossibility built into the geometry of the universe. Compton scattering would occur continuously as high-energy photons interact with the electrons in your spacecraft's atoms. At light speed, even low-energy photons from the cosmic microwave background would appear as high-energy gamma rays due to relativistic blue shifting. These photons would scatter off electrons, transferring energy and momentum in ways that would gradually disintegrate your spacecraft's atomic structure. The concept of proper acceleration becomes infinite at light speed, meaning that any attempt to reach the cosmic speed limit would require infinite force applied for an infinite time. This isn't just an engineering challenge, it's a mathematical impossibility. The universe has built an infinite wall that prevents massive objects from reaching light speed, no matter how advanced your technology becomes. Synchrotron radiation losses would drain energy from any charged particles in your spacecraft as they spiral around magnetic field lines. At light speed, these energy losses would be enormous, creating a continuous power drain that would quickly exhaust any energy source. Now, your ship's electronics, which depend on the controlled movement of electrons, would be continuously losing energy to synchrotron radiation, causing system failures throughout your vessel. The concept of simultaneity breakdown creates paradoxes that extend beyond simple time dilation. At light speed, the relativity of simultaneity becomes so extreme that events in your past light cone and future light cone become scrambled. You'd exist at a point where the normal causal structure of space-time breaks down, making it impossible to distinguish between cause and effect, past and future, or even existence and non-existence. Pair production would occur continuously in the intense electromagnetic fields surrounding your light-speed spacecraft. When photons have sufficient energy, they can spontaneously create electron-positron pairs from the vacuum. At light speed, the electromagnetic fields would be so intense that this process would happen constantly, creating a cloud of matter and antimatter particles around your ship. These particles would immediately annihilate, releasing gamma radiation and contributing to the lethal radiation environment. The concept of rest energy becomes paradoxical at light speed because your kinetic energy approaches infinity while your rest energy remains finite. It creates a situation where your total energy is infinite, which is physically meaningless. The universe doesn't allow infinite energies to exist in finite regions of space, which is another way that physics prevents light-speed travel for massive objects. Quantum tunneling effects would become chaotic and unpredictable in the extreme conditions of light-speed travel. Normally, quantum tunneling allows particles to pass through energy barriers with predictable probabilities. But at light speed, the energy scales involved would make quantum tunneling behavior completely random and potentially destructive. Particles in your spacecraft might spontaneously tunnel to different locations, causing your ship's structure to become quantum mechanically unstable. The concept of field equations breaks down at light speed because Einstein's field equations, which describe how matter and energy curve space-time, become singular for objects moving at the cosmic speed limit. The mathematics that governs the relationship between matter, energy, space and time simply doesn't work for light-speed massive objects. You'd be trying to exist in a state that the fundamental equations of physics cannot describe. Vacuum fluctuations would be amplified dramatically by the intense conditions around your light-speed spacecraft. The quantum vacuum is normally filled with virtual particles that appear and disappear on timescales too short to observe directly. But the extreme electromagnetic fields and gravitational effects of light-speed travel would amplify these fluctuations, potentially making them real and observable. You'd be surrounded by a chaos of spontaneously appearing and disappearing particles. The concept of thermodynamic equilibrium becomes impossible to maintain at light speed because the extreme conditions would drive all systems far from equilibrium. Your spacecraft's life support systems, designed to maintain stable temperature, pressure, and chemical composition, would be overwhelmed by the continuous input of energy from particle bombardment and radiation. You'd be trapped in a system that's thermodynamically unstable and rapidly evolving toward maximum entropy. Magnetic monopole effects, if these hypothetical particles exist, would become significant at the energy scales involved in light-speed travel. Some theories predict that magnetic monopoles could be created in high-energy collisions, and the continuous bombardment of your spacecraft by relativistic particles might produce these exotic objects. Magnetic monopoles would have electromagnetic properties unlike anything in normal matter, potentially creating unpredictable and dangerous field configurations around your ship. The phenomenon of vacuum birefringence would manifest in the intense electromagnetic fields surrounding your light-speed spacecraft, causing empty space itself to behave like a polarizing filter. This quantum electrodynamic effect, normally only observable near neutron stars with magnetic fields trillions of times stronger than Earth's, would begin operating around your ship due to the extreme field strengths generated by your relativistic motion. The vacuum would literally split light into different polarizations, creating optical chaos that would interfere with any attempt to navigate or communicate. Spontaneous symmetry breaking could occur in the quantum field surrounding your spacecraft as the enormous energy densities approach the scales where fundamental forces unify. At these extreme energies, the electromagnetic and weak nuclear forces might spontaneously separate in unexpected ways, creating regions of space around your ship where the laws of physics operate differently than in normal vacuum. You'd be surrounded by bubbles of altered reality where familiar physical constants might have different values. The concept of locality breaks down at light speed because information about your spacecraft's state cannot propagate to distant observers fast enough to maintain causal connections. In normal physics, events at one location can only influence events at other locations through signals that travel at or below light speed. But when you're moving at light speed, this causal structure collapses, creating a situation where your spacecraft exists in a state of causal isolation from the rest of the universe. Hawking Unruh radiation would manifest around your spacecraft as the extreme acceleration required to reach light speed creates the appearance of thermal radiation in what should be empty vacuum. From your accelerating reference frame, the quantum vacuum would appear to be filled with hot, thermal radiation that would cook you alive. This isn't just a theoretical effect, it's a fundamental consequence of quantum field theory in curved space-time that would make your journey lethal even in the absence of any other matter. The concept of gauge invariance, which ensures that the laws of electromagnetism remain consistent regardless of how we choose to describe electromagnetic fields, becomes problematic at light speed. The extreme field configurations generated by your relativistic motion might break gauge symmetry in ways that make electromagnetic phenomena behave unpredictably. Your spacecraft's electrical systems would be operating in a regime where the normal rules of electromagnetism might not apply. Vacuum decay catalysis becomes a terrifying possibility when the enormous energy densities of light-speed travel interact with the quantum vacuum. Some theories suggest that our universe exists in a metastable vacuum state that could be triggered into a lower energy configuration by sufficiently extreme conditions. Your light-speed spacecraft might accidentally catalyze a vacuum decay event that would propagate outward at light speed, potentially destroying the structure of space-time itself across vast regions of the universe. The concept of renormalization, which allows physicists to deal with infinite quantities in quantum field theory, breaks down at the energy scales involved in light-speed travel. Normally, infinite quantities that appear in quantum calculations can be absorbed into redefinitions of physical constants, but at light speed, these infinities become so severe that no amount of mathematical manipulation can make them disappear. You'd be operating in a regime where quantum field theory itself becomes mathematically inconsistent. Gravitational wave emission would be continuous and enormous as your light-speed spacecraft accelerates through space-time. Any accelerating mass produces gravitational waves, but at light speed, these waves would carry away energy at a rate that would quickly drain any power source. Your ship would be continuously broadcasting its location across the galaxy through gravitational radiation while simultaneously losing the energy needed to maintain its impossible velocity. The concept of unitarity, which ensures that quantum mechanical probabilities always add up to 100%, might be violated in the extreme conditions of light-speed travel. Unitarity is fundamental to quantum mechanics. It's what ensures that particles don't spontaneously disappear or appear from nothing. But the intense radiation and particle creation around your spacecraft might create conditions where unitarity breaks down, leading to unpredictable and potentially catastrophic quantum mechanical behavior. Magnetic reconnection events would occur continuously in the chaotic magnetic fields generated by your light-speed motion through the galaxy's magnetic field. These explosive releases of magnetic energy, normally seen in solar flares and planetary magnetospheres, would happen constantly around your spacecraft as magnetic field lines are stretched, twisted, and broken by your passage. Each reconnection event would release enormous amounts of energy, contributing to the already lethal radiation environment. The concept of supersymmetry, if it exists in nature, might be spontaneously broken in the extreme conditions around your light-speed spacecraft. Supersymmetry is a theoretical framework that predicts the existence of partner particles for every known particle. If supersymmetry is real, the enormous energy densities of light-speed travel might break this symmetry in ways that create exotic particles and forces that don't exist under normal conditions. You'd be surrounded by physics that operates according to rules we've never observed. Vacuum Cherenkov radiation might become possible in the modified vacuum around your spacecraft, where quantum effects have altered the effective speed of light in the medium. Normally, Cherenkov radiation only occurs when particles move faster than light in a material medium, but the quantum vacuum modifications around your ship might create conditions where this effect can occur in empty space. You'd be generating Cherenkov radiation in vacuum, creating additional energy losses and radiation hazards. The concept of CPT symmetry, which states that the laws of physics remain the same under combined charge conjugation, parity reversal, and time reversal, might be violated in the extreme conditions of light-speed travel. CPT symmetry is one of the most fundamental principles in physics, and its violation would indicate that the basic structure of space-time itself is being distorted by your motion. You'd be creating conditions where the fundamental symmetries of nature break down. Quantum chromodynamic flux tubes might form between quarks in your spacecraft's atomic nuclei as the extreme conditions approach the energy scales where the strong nuclear force operates. These flux tubes, normally confined within individual protons and neutrons, might stretch across macroscopic distances in the intense fields around your ship. Your spacecraft's matter would begin to exhibit properties normally only seen in quark matter, potentially leading to the formation of strange matter that could convert normal matter into exotic forms. The concept of holographic duality, which suggests that information in a volume of space can be encoded on its boundary, becomes problematic when your spacecraft is moving at light speed. The holographic principle relies on the ability to establish causal connections between the bulk and the boundary, but at light speed, these connections break down. You'd exist in a state where the normal relationship between information and space-time geometry becomes undefined. Vacuum polarization cascades would develop in the intense electromagnetic fields around your spacecraft, creating avalanches of particle creation and annihilation. As virtual particles become real in the strong fields, they would create additional electromagnetic disturbances that could trigger more particle creation, leading to a runaway cascade effect. You'd be surrounded by an exponentially growing cloud of particles and radiation that would quickly become uncontrollable. The concept of asymptotic freedom, which describes how the strong nuclear force becomes weaker at higher energies, might reverse in the extreme conditions of light-speed travel. At the energy scales involved, the strong force might begin to strengthen again, leading to unexpected nuclear phenomena. The protons and neutrons in your spacecraft's atoms might begin to interact in ways that don't occur under normal conditions, potentially leading to exotic nuclear reactions. Topological defects in spacetime might form in the wake of your light-speed spacecraft as the extreme gravitational effects create regions where the normal structure of space and time becomes twisted or broken. These defects, similar to cosmic strings or domain walls, would persist long after your passage and could have unpredictable effects on any matter that encounters them. You'd be leaving scars in the fabric of spacetime itself. The concept of information paradox resolution becomes impossible at light speed because the normal mechanisms that preserve quantum information break down in the extreme conditions. Quantum mechanics requires that information be preserved even in the most extreme physical processes, but the combination of intense radiation, particle creation, and space-time distortion around your spacecraft might destroy information in ways that violate fundamental principles of quantum mechanics. Vacuum instability might be triggered by the enormous energy densities of light-speed travel, causing the quantum vacuum to undergo phase transitions that alter the fundamental properties of empty space. These phase transitions could propagate outward from your spacecraft at light speed, creating expanding bubbles of altered vacuum that would change the laws of physics for any matter they encounter. You'd be accidentally rewriting the fundamental constants of nature wherever you travel. The phenomenon of dimensional reduction would begin manifesting as the extreme gravitational fields generated by your light-speed spacecraft approach the Planck scale, where quantum gravity effects become dominant. At these energy densities, the normal three-dimensional structure of space might break down, causing your spacecraft to exist in a state where spatial dimensions become ill-defined. You'd be traveling through a region where the very concept of three-dimensional space loses meaning, making navigation and even existence problematic. Quantum decoherence would accelerate exponentially in the chaotic environment surrounding your light-speed spacecraft. Normally, quantum systems maintain their coherent superposition states for brief periods before environmental interactions cause decoherence. But the intense radiation, particle bombardment, and electromagnetic chaos around your ship would cause instantaneous decoherence of any quantum states. This would make quantum computing impossible and could potentially affect the quantum mechanical processes that hold your atoms together. The concept of causal diamonds, regions of space-time that can be causally connected to a given event, becomes meaningless at light speed. Normally, every point in space-time has a well-defined causal diamond that determines which events can influence it and which events it can influence. But when you're moving at light speed, these causal diamonds collapse to zero size, meaning you exist in a state where you cannot causally interact with anything else in the universe. Vacuum metastability could be catastrophically disrupted by the enormous energy densities of your light-speed journey. Our universe might exist in a false vacuum state that appears stable but could decay to a lower energy state if triggered by sufficient energy input. The quantum field fluctuations around your spacecraft might provide exactly the trigger needed to initiate vacuum decay, creating an expanding bubble of true vacuum that would annihilate everything in its path at light speed. The concept of emergent spacetime breaks down when your spacecraft approaches the energy scales, where space and time themselves might be emergent properties of more fundamental quantum information. Some theories suggest that spacetime emerges from quantum entanglement networks, but the extreme conditions of light-speed travel might disrupt these networks so severely that space-time itself becomes unstable around your ship. You'd be traveling through regions where space and time are literally falling apart. Quantum gravity effects would become dominant as your spacecraft's enormous relativistic mass creates gravitational fields strong enough to significantly curve space-time on quantum scales. At these scales, the smooth geometry of Einstein's general relativity breaks down and is replaced by a foamy, fluctuating structure where space and time become quantized. Your ship would be navigating through a quantum gravitational storm where the normal rules of geometry no longer apply. The concept of black hole formation becomes inevitable as your relativistic mass approaches the critical density required for gravitational collapse. Even if your spacecraft starts with a modest rest mass, the enormous kinetic energy at light speed would create gravitational effects equivalent to a black hole. You wouldn't just be traveling at light speed, you'd be transforming into a black hole with an event horizon that would prevent any information about your journey from ever reaching the outside universe. Hawking radiation emission would begin as your spacecraft approaches black hole densities, causing you to slowly evaporate through quantum mechanical processes. The temperature of this radiation would be inversely proportional to your mass, so as you lose mass through Hawking radiation, the temperature would increase, accelerating the evaporation process. You'd be caught in a runaway feedback loop where your spacecraft literally evaporates itself out of existence. The concept of holographic entropy bounds would be violated by the enormous information content of your light-speed spacecraft compressed into a region approaching its Schwarzschild radius. The holographic principle states that the maximum entropy in any region is proportional to its surface area, not its volume. But your spacecraft would contain more information than could be encoded on its surface, creating a fundamental violation of quantum information theory that might cause reality itself to become inconsistent. Vacuum polarization would reach extreme levels as the intense electromagnetic fields around your spacecraft approach the Schwinger limit, where virtual particle pairs become real. At this critical field strength, the quantum vacuum breaks down and begins producing matter and antimatter from pure energy. Your ship would be surrounded by a continuous creation of particle pairs that would immediately annihilate, releasing gamma radiation and contributing to the already lethal radiation environment. The concept of gauge field topology becomes chaotic in the extreme electromagnetic fields generated by your light-speed motion. Normally, electromagnetic fields have well-defined topological properties that remain stable over time. But the intense field configurations around your spacecraft might create topological defects, regions where the electromagnetic field becomes twisted or knotted in ways that cannot be smoothly unwound. These defects would store enormous amounts of energy and could release it unpredictably. Quantum chromodynamic confinement might break down as the extreme energy densities approach the scale where quarks and gluons become deconfined. Normally, quarks are permanently confined within protons and neutrons by the strong nuclear force. But at the energy scales of light-speed travel, this confinement might break down, allowing quarks to exist freely in a quark-gluon plasma state. Your spacecraft's matter would undergo a phase transition to an exotic state that doesn't exist under normal conditions. The concept of supersymmetric partner particles might be spontaneously created in the intense energy fields around your spacecraft. If supersymmetry exists in nature, every known particle has a heavier supersymmetric partner. The enormous energy densities of light-speed travel might provide enough energy to create these exotic particles, which would then decay rapidly, releasing additional energy and exotic radiation. You'd be surrounded by a zoo of particles that don't exist anywhere else in the current universe. Vacuum birefringence would split light into ordinary and extraordinary rays as it passes through the polarized quantum vacuum around your spacecraft. This effect, predicted by quantum electrodynamics but normally only observable in the strongest magnetic fields in the universe, would create optical chaos around your ship. Any attempt to use light for navigation, communication, or observation would be frustrated by the vacuum's altered optical properties. The concept of asymptotic safety in quantum gravity might be violated by the extreme conditions of light-speed travel. Asymptotic safety is a proposed mechanism that could make quantum gravity mathematically consistent at all energy scales, but the energy densities around your spacecraft might exceed the scales where asymptotic safety operates, leading to a breakdown of quantum gravity theory itself. You'd be operating in a regime where our most fundamental theories of spacetime become meaningless. Magnetic monopole pair production might occur in the intense electromagnetic fields surrounding your light-speed spacecraft. While magnetic monopoles have never been observed, some theories predict they could be created in sufficiently strong electromagnetic fields. These exotic particles would have magnetic charges analogous to electric charges, creating electromagnetic phenomena unlike anything in normal matter. Your ship would be surrounded by magnetic field configurations that don't exist anywhere else in nature. The concept of quantum error correction breaks down when the error rate exceeds the threshold for maintaining quantum information. The intense radiation and particle bombardment around your spacecraft would create quantum errors faster than any conceivable error correction system could fix them. This would make it impossible to maintain the quantum coherence necessary for the chemical bonds that hold your spacecraft together, potentially causing your ship to literally fall apart at the atomic level. Vacuum decay nucleation might be triggered by the extreme curvature of spacetime around your light-speed spacecraft. Some theories suggest that vacuum decay could be catalyzed by gravitational effects, particularly in regions of high spacetime curvature. The intense gravitational fields generated by your relativistic mass might provide exactly the conditions needed to nucleate a vacuum decay bubble, initiating the destruction of spacetime itself in an expanding sphere around your location. The concept of emergent gravity breaks down when the quantum information networks that supposedly give rise to gravitational effects are disrupted by the extreme conditions of light-speed travel. If gravity emerges from quantum entanglement, as some theories suggest, then the chaos around your spacecraft might disrupt these entanglement networks so severely that gravity itself becomes ill-defined. You'd be traveling through regions where one of the fundamental forces of nature ceases to operate normally. Quantum field theory renormalization becomes impossible when the energy scales exceed all known cutoff parameters. Normally, the infinite quantities that appear in quantum field calculations can be absorbed into redefinitions of physical constants through renormalization procedures. But at the energy scales of light-speed travel, these infinities become so severe that no amount of mathematical manipulation can make the theory consistent. You'd be operating in a regime where quantum field theory itself breaks down completely. The phenomenon of spontaneous black hole formation would become inevitable as your spacecraft's energy density exceeds the Planck density, approximately 10 to the 96th kilograms per cubic meter. At this point, the distinction between matter and spacetime curvature breaks down completely, and your spacecraft would collapse into a microscopic black hole regardless of its original size or composition. This isn't just gravitational collapse, it's the fundamental limit where matter can no longer exist as discrete particles and must become a singularity. Quantum tunneling through the light barrier reveals another impossibility built into the fabric of reality. While quantum mechanics allows particles to tunnel through energy barriers that should be classically forbidden, the mathematics of special relativity creates an infinite energy barrier at light speed for massive objects. No amount of quantum tunneling can overcome an infinite barrier, making light-speed travel impossible even through quantum mechanical loopholes. The concept of information scrambling would reach its maximum rate in the chaotic environment surrounding your light-speed spacecraft. Information scrambling describes how quantum information becomes distributed throughout a system, and black holes are the fastest scramblers in the universe. As your ship approaches black hole conditions, any information about its original state would be scrambled and distributed so rapidly that recovery would become impossible even in principle. Vacuum polarization cascades would create runaway feedback loops as virtual particles become real in the intense electromagnetic fields, only to create even stronger fields that produce more particles. This process would continue exponentially, creating an ever-expanding cloud of matter and antimatter around your spacecraft. The energy density would grow without bound until it triggers vacuum decay or black hole formation, making your journey catastrophically unstable. The concept of gauge gravity duality suggests that certain gravitational theories are equivalent to gauge theories in one fewer dimension. At the extreme energy scales of light-speed travel, this duality might manifest in unexpected ways, causing your three-dimensional spacecraft to exhibit properties of a two-dimensional system. You'd exist in a state where the normal dimensionality of space becomes ambiguous, making physical existence problematic. Quantum chromodynamic flux tubes would stretch across macroscopic distances as the extreme energy densities approach the scale where the strong nuclear force operates. These tubes of concentrated strong force field would connect quarks across your entire spacecraft, potentially causing the atomic nuclei in different parts of your ship to become quantum mechanically entangled. Your spacecraft would transform into a single, giant hadron held together by strong force interactions. The concept of cosmic censorship, which prevents naked singularities from forming in general relativity, might be violated by the extreme conditions of light-speed travel. Cosmic censorship ensures that singularities are always hidden behind event horizons, but the rapid formation of black holes from your relativistic mass might create situations where singularities become visible to external observers. This would violate one of the fundamental principles that keep general relativity mathematically consistent. Vacuum instability propagation would create expanding bubbles of altered spacetime that travel outward from your spacecraft at light speed. These bubbles would contain regions where the fundamental constants of physics have different values, potentially making chemistry and nuclear physics operate according to different rules. Any matter that encounters these bubbles would be transformed or destroyed as it tries to adapt to the altered physical laws. The concept of quantum gravity phenomenology becomes directly relevant as your spacecraft's gravitational field approaches the strength where quantum effects dominate over classical general relativity. At these scales, space-time itself becomes subject to quantum uncertainty, creating a foamy structure where the smooth geometry of Einstein's theory breaks down. You'd be navigating through a quantum gravitational storm where space and time fluctuate wildly on microscopic scales. Hawking Unruh radiation would reach temperatures comparable to the core of massive stars as the extreme acceleration required for light-speed travel creates thermal radiation from the quantum vacuum. This radiation would be so intense that it would instantly vaporize any known material, making survival impossible even if all other effects could somehow be overcome. The vacuum itself would become a furnace hot enough to trigger nuclear fusion reactions. The concept of holographic complexity, which measures the computational difficulty of reconstructing quantum states from holographic boundaries, would exceed all possible bounds around your light-speed spacecraft. The quantum information content of your ship would be so complex that it couldn't be encoded on any possible holographic surface, violating fundamental principles of quantum information theory and potentially causing reality itself to become computationally inconsistent. Magnetic monopole condensation might occur in the extreme electromagnetic field surrounding your spacecraft, creating a phase of matter where magnetic charges behave like a superconductor. This exotic state would have electromagnetic properties completely unlike normal matter, potentially creating magnetic field configurations that could tear apart atomic nuclei through electromagnetic forces alone. Your ship would be surrounded by a magnetic superconductor that doesn't exist anywhere else in the universe. The concept of emergent time breaks down when the quantum entanglement networks that supposedly give rise to temporal evolution are disrupted by the extreme conditions around your spacecraft. Some theories suggest that time itself emerges from quantum entanglement patterns, but the chaos of light-speed travel might disrupt these patterns so severely that time ceases to flow normally. You'd exist in a state where the passage of time becomes ill-defined or stops entirely. Vacuum decay catalysis would become inevitable as the enormous energy densities exceed the threshold for triggering phase transitions in the quantum vacuum. The false vacuum that might characterize our current universe would decay to a true vacuum state, releasing enormous amounts of energy and fundamentally altering the laws of physics. This decay would propagate outward at light speed, potentially destroying the structure of space-time across vast regions of the universe. The concept of quantum error correction thresholds would be catastrophically exceeded, as the error rate from radiation and particle bombardment surpasses any possible correction capability. Quantum systems can only maintain coherence if errors can be corrected faster than they accumulate, but the extreme environment around your spacecraft would create errors at rates that exceed the fundamental limits of quantum error correction. This would cause the quantum mechanical bonds holding your atoms together to decohere and fail. Gravitational wave memory effects would permanently alter the structure of spacetime in the wake of your light-speed passage. These persistent changes in spacetime geometry would remain long after your spacecraft has moved on, creating regions where the normal properties of space and time are permanently modified. You'd be leaving scars in the fabric of reality that could affect any matter or energy that encounters them in the future. The concept of supersymmetric dark matter might be spontaneously created in the intense energy fields around your spacecraft, populating your local region with exotic particles that interact only weakly with normal matter. These particles would carry away energy and momentum in unpredictable ways, creating additional instabilities in your ship's motion while potentially altering the local dark matter density in ways that could affect nearby gravitational fields. Quantum chromodynamic phase transitions would occur as the extreme energy densities cause normal nuclear matter to undergo transitions to exotic phases like quark matter or strange matter. These phase transitions would release enormous amounts of energy while fundamentally altering the properties of your spacecraft's material. Your ship would literally transform into exotic matter that doesn't exist under normal conditions anywhere in the universe. The concept of causal structure preservation becomes impossible when your light-speed motion creates closed, time-like curves and other violations of causality. The extreme gravitational effects of your relativistic mass would warp space-time so severely that the normal ordering of cause and effect breaks down. You'd exist in a region where events can be their own causes, creating logical paradoxes that make physical existence meaningless. Vacuum birefringent saturation would occur when the electromagnetic fields around your spacecraft exceed the critical strength where the quantum vacuum can no longer respond linearly to field changes. Beyond this point, the vacuum would exhibit nonlinear optical properties that could focus or defocus electromagnetic radiation in unpredictable ways. Any attempt to use electromagnetic signals for navigation or communication would be frustrated by the vacuum's chaotic optical behavior. The concept of holographic entanglement entropy would exceed the maximum possible values as the quantum entanglement in your spacecraft's matter approaches the limits imposed by the holographic principle. This would create a situation where the quantum information content of your ship cannot be consistently described by any known theoretical framework, potentially causing the mathematical description of reality itself to become inconsistent in your vicinity. The phenomenon of quantum field theory breakdown becomes complete when the energy scales around your light-speed spacecraft exceed the Planck energy, approximately 10 to the 19 billion electron volts. At this point, all known quantum field theories become mathematically inconsistent, and the fundamental particles that make up your spacecraft can no longer be described by any existing theoretical framework. You'd be operating in a regime where the basic language of physics becomes meaningless, making prediction or understanding impossible. Space-time foam effects would manifest on macroscopic scales around your spacecraft as quantum gravitational fluctuations become large enough to affect the structure of space and time on human observable dimensions. Normally, these fluctuations only occur at the Planck scale, but the extreme energy densities of light-speed travel would amplify them until space-time itself becomes visibly turbulent. You'd be traveling through a region where space and time are literally boiling with quantum uncertainty. The concept of unitarity violation becomes unavoidable when the extreme conditions around your spacecraft create situations where quantum mechanical probabilities no longer sum to 100%. Unitarity is fundamental to quantum mechanics. It ensures that particles don't spontaneously appear or disappear without cause. But the intense radiation, particle creation, and space-time distortion around your ship would create conditions where unitarity breaks down, leading to unpredictable and potentially catastrophic quantum behavior. Vacuum polarization saturation would cause the quantum vacuum to reach its maximum possible response to electromagnetic fields, beyond which it can no longer absorb additional field energy. This saturation would create a nonlinear medium where electromagnetic waves behave in completely unexpected ways, potentially focusing into intense beams or scattering chaotically. The vacuum itself would become an active participant in electromagnetic phenomena rather than a passive medium. The concept of asymptotic freedom reversal might occur in the extreme conditions around your spacecraft, causing the strong nuclear force to begin strengthening at high energies rather than weakening. This would lead to nuclear phenomena that don't exist under normal conditions, potentially causing the protons and neutrons in your spacecraft's atoms to bind together in exotic ways or undergo reactions that release enormous amounts of energy. Quantum chromodynamic string formation would create macroscopic strings of pure, strong force field connecting quarks across vast distances within your spacecraft. These strings would store enormous amounts of energy and could snap like rubber bands, releasing energy equivalent to nuclear explosions. Your ship would be threaded with invisible strings of concentrated nuclear force that could tear it apart from within. The concept of information paradox resolution becomes impossible when the normal mechanisms for preserving quantum information are overwhelmed by the extreme conditions of light-speed travel. Quantum mechanics requires that information be conserved even in the most extreme physical processes. But the combination of black hole formation, vacuum decay, and space-time breakdown around your spacecraft would destroy information in ways that violate the fundamental principles of quantum theory. Magnetic monopole pair production would occur continuously in the intense electromagnetic fields surrounding your spacecraft, creating exotic particles with magnetic charges that don't exist in normal matter. These monopoles would interact with electromagnetic fields in ways that could create runaway instabilities, potentially causing electromagnetic field configurations to grow without bound until they trigger vacuum decay or other catastrophic phenomena. The concept of gauge invariance breakdown would occur when the extreme electromagnetic fields around your spacecraft exceed the scales where gauge symmetry remains valid. Gauge invariance ensures that the laws of electromagnetism remain consistent regardless of how we choose to describe electromagnetic potentials. But at extreme field strengths, this symmetry might break down, causing electromagnetic phenomena to behave in unpredictable and potentially dangerous ways. Vacuum decay nucleation would become inevitable as the extreme curvature of space-time around your light-speed spacecraft provides the perfect conditions for triggering phase transitions in the quantum vacuum. The false vacuum that characterizes our current universe would decay to a lower energy state, creating an expanding bubble of altered space-time that would propagate outward at light speed, potentially destroying the familiar structure of physics across vast regions of the cosmos. The concept of emergent space-time collapse would occur when the quantum information networks that supposedly give rise to space and time are disrupted beyond repair by the extreme conditions around your spacecraft. If space-time emerges from quantum entanglement patterns, as some theories suggest, then the chaos of light-speed travel would disrupt these patterns so severely that space and time themselves would cease to exist in any meaningful sense around your ship. Quantum gravity effects would create regions around your spacecraft where the normal concepts of distance, duration, and causality become undefined. At the Planck scale, quantum uncertainty makes the very notion of precise position and time meaningless, but the extreme energy densities of light-speed travel would amplify these effects until they become macroscopically observable. You'd be traveling through regions where the basic structure of reality becomes quantum, mechanically fuzzy. The concept of holographic duality breakdown would occur when the extreme conditions around your spacecraft exceed the scales where the correspondence between gravitational and gauge theories remains valid. This duality is one of the most important theoretical tools in modern physics, but the energy densities of light-speed travel might exceed its domain of applicability, leaving us without any theoretical framework for understanding what happens to your spacecraft. Vacuum instability cascades would create chain reactions where one region of unstable vacuum triggers instability in neighboring regions, leading to an exponentially expanding zone of altered physics around your spacecraft. These cascades would propagate at light speed, creating an ever-growing bubble where the fundamental constants of nature have different values, potentially making chemistry, nuclear physics, and even atomic structure operate according to completely different rules. The concept of quantum error correction failure would become complete when the error rate from the extreme environment around your spacecraft exceeds the fundamental theoretical limits for maintaining quantum coherence. Even perfect quantum error correction systems have threshold error rates beyond which they cannot function, and the radiation, particle bombardment, and field fluctuations around your ship would far exceed these thresholds, causing the quantum mechanical processes that hold matter together to fail catastrophically. Gravitational wave nonlinearity would cause the intense gravitational radiation from your spacecraft to interact with itself, creating gravitational shock waves and other exotic phenomena that don't occur in the weak field regime, where general relativity is normally applied. These nonlinear effects could focus gravitational energy into intense beams or create standing wave patterns that would further distort spacetime around your ship in unpredictable ways. The concept of supersymmetry breaking would occur spontaneously in the extreme energy fields around your spacecraft, potentially creating a zoo of exotic particles that don't exist under normal conditions. If supersymmetry exists in nature, the energy densities of light-speed travel would be sufficient to break this symmetry in ways that could fundamentally alter the particle physics in your local region, creating new forces and interactions that we've never observed. Vacuum polarization runaway would create feedback loops where the polarization of the quantum vacuum creates electromagnetic fields that cause even more polarization, leading to exponentially growing field strengths that could trigger vacuum decay or other catastrophic phenomena. The vacuum would become an active amplifier of electromagnetic disturbances rather than a passive medium, creating instabilities that could grow without bound. The concept of cosmic censorship violation would occur as the rapid formation of black holes from your relativistic mass creates naked singularities that are visible to external observers. Cosmic censorship is supposed to ensure that singularities are always hidden behind event horizons, but the extreme conditions of light-speed travel might create situations where this principle fails, exposing the mathematical infinities of general relativity to the outside universe. Quantum chromodynamic flux tube networks would form a web of strong force field lines throughout your spacecraft, connecting quarks across macroscopic distances and potentially causing your ship's matter to behave like a single, giant atomic nucleus. These flux tubes would store enormous amounts of energy and could interact in ways that trigger exotic nuclear reactions or phase transitions to strange matter that could convert normal matter into even more exotic forms. The concept of holographic complexity overflow would occur when the quantum information content of your spacecraft exceeds the computational capacity of any possible holographic encoding. The holographic principle suggests that all information in a volume can be encoded on its boundary, but the extreme conditions of light-speed travel might create quantum states so complex that they cannot be encoded on any finite surface, violating fundamental principles of quantum information theory. The phenomenon of dimensional transmutation would begin manifesting as the extreme energy scales around your light-speed spacecraft approach the point where dimensionless coupling constants become dimensional quantities. This breakdown of scale invariance would cause the fundamental forces to behave in completely unexpected ways, potentially altering the strength of electromagnetic, weak and strong interactions in your local region. The very constants that define how particles interact would become variables that change unpredictably with energy and position. Quantum field theory vacuum selection would become chaotic as the extreme conditions around your spacecraft create multiple possible vacuum states with different physical properties. Normally, quantum fields settle into a unique ground state, but the enormous energy densities of light-speed travel could create regions where multiple vacuum states coexist or rapidly fluctuate between different configurations. Your ship would be traveling through a patchwork of different physical realities, each with its own laws of physics. The concept of causal diamond collapse would occur when your light-speed motion reduces the causal diamond around your spacecraft to zero volume. Causal diamonds define the regions of space-time that can causally influence or be influenced by a given event, but at light speed, these regions shrink to nothing. You'd exist in a state of complete causal isolation, unable to influence or be influenced by anything else in the universe, making your existence physically meaningless. Vacuum birefringent saturation would cause the polarized quantum vacuum around your spacecraft to reach its maximum possible response to electromagnetic fields. Beyond this saturation point, the vacuum would exhibit highly nonlinear optical properties, potentially creating regions where light travels at different speeds in different directions, or where electromagnetic waves spontaneously change frequency. The fundamental properties of light itself would become chaotic and unpredictable. The concept of emergent gravity breakdown would occur when the quantum entanglement networks that supposedly give rise to gravitational effects are disrupted beyond repair by the extreme conditions around your spacecraft. If gravity emerges from quantum information patterns, as some theories suggest, then the chaos of light-speed travel would destroy these patterns so completely that gravity itself would cease to operate normally, creating regions where one of the fundamental forces simply doesn't exist. quantum chromodynamic confinement failure would allow quarks to exist freely outside of protons and neutrons as the extreme energy densities overcome the strong force that normally keeps them bound. This deconfinement would transform your spacecraft's matter into a quark-gluon plasma, an exotic state that only existed in the first microseconds after the Big Bang. Your ship would literally revert to a primordial state of matter that hasn't existed in the universe for nearly 14 billion years. The concept of holographic entanglement entropy maximization would occur when the quantum entanglement in your spacecraft's matter reaches the absolute maximum allowed by the holographic principle. This would create a situation where any additional entanglement would violate fundamental bounds on quantum information, potentially causing the mathematical description of your spacecraft to become inconsistent. Reality itself would become computationally unstable in your vicinity. Vacuum decay, bubble nucleation would become inevitable as the extreme space-time curvature around your light-speed spacecraft provides the perfect seed for triggering phase transitions in the quantum vacuum. These bubbles would expand at light speed, carrying with them altered physical laws that could make atoms unstable, change the strength of fundamental forces, or even alter the dimensionality of space itself. You'd be accidentally rewriting the basic structure of reality wherever you travel. The concept of quantum gravity foam amplification would cause the normally microscopic fluctuations in space-time geometry to grow to macroscopic scales around your spacecraft. Space and time would become visibly turbulent, with regions where distances and durations fluctuate wildly due to quantum uncertainty. You'd be navigating through a storm of space-time itself, where the basic concepts of position and time lose their meaning. Magnetic monopole condensation would create a phase of matter around your spacecraft, where magnetic charges behave like a superconductor, expelling magnetic fields and creating perfect magnetic conductivity. This exotic state would have electromagnetic properties completely unlike anything in normal matter, potentially creating magnetic field configurations that could induce nuclear reactions through electromagnetic forces alone. Your ship would be surrounded by a magnetic superconductor that violates our normal understanding of electromagnetism. The concept of supersymmetric partner particle creation would populate the region around your spacecraft with exotic particles that don't exist under normal conditions. If supersymmetry is real, the enormous energy densities of light-speed travel would create sparticles, the supersymmetric partners of ordinary particles. These exotic particles would interact through forces we've never observed, potentially creating new types of radiation and field effects that could be even more dangerous than conventional physics predicts. Vacuum polarization, cascade amplification would create runaway feedback loops where the creation of virtual particle pairs generates electromagnetic fields that create even more particle pairs, leading to exponentially growing energy densities. This process would continue until it triggers vacuum decay, black hole formation, or other catastrophic phenomena. The quantum vacuum would become an active amplifier of disturbances rather than a passive medium. The concept of gauge-gravity duality breakdown would occur when the extreme conditions around your spacecraft exceed the domain where the correspondence between gravitational and gauge theories remains valid. This duality is one of our most powerful theoretical tools, but the energy scales of light-speed travel might exceed its applicability, leaving us without any mathematical framework for understanding what happens to matter and energy in such extreme conditions. Quantum chromodynamic flux tube percolation would create a network of strong force field lines that spans your entire spacecraft, connecting quarks across macroscopic distances and potentially causing your ship to behave like a single, giant hadron. These flux tubes would store enormous amounts of energy and could interact in ways that trigger phase transitions to even more exotic forms of matter, such as strange matter that could convert normal matter into strange quarks. The concept of information scrambling saturation would occur when the rate of quantum information mixing around your spacecraft reaches the fundamental maximum allowed by quantum mechanics. Black holes are the fastest scramblers in the universe, and as your ship approaches black hole conditions, information about its original state would be scrambled so rapidly and completely that recovery would become impossible even in principle, violating the fundamental requirement that quantum information be conservable. Vacuum instability propagation would create expanding spheres of altered spacetime that travel outward from your spacecraft at light speed, carrying with them regions where the fundamental constants of physics have different values. These bubbles would transform any matter they encounter, potentially making chemistry operate according to different rules, altering nuclear stability, or even changing the number of spatial dimensions. You'd be accidentally terraforming reality itself. The concept of asymptotic safety violation would occur when the energy scales around your spacecraft exceed the domain where quantum gravity remains mathematically consistent. Asymptotic safety is a proposed mechanism that could make quantum gravity well-behaved at all energy scales, but the extreme conditions of light-speed travel might exceed even these theoretical limits, causing the mathematical description of spacetime itself to become meaningless. Hawking radiation temperature divergence would occur as your spacecraft approaches black hole formation, causing the thermal radiation from quantum vacuum fluctuations to reach temperatures that exceed the Planck temperature, the highest possible temperature in physics. At this point, the very concept of temperature breaks down, and thermal radiation becomes so energetic that it can spontaneously create black holes from pure energy, leading to a cascade of black hole formation and evaporation. The concept of holographic complexity explosion would occur when the computational difficulty of describing your spacecraft's quantum state exceeds all possible bounds. The holographic principle suggests that quantum states can be encoded on lower dimensional boundaries, but the extreme conditions of light-speed travel would create states so complex that they couldn't be encoded on any finite surface, potentially causing the mathematical description of reality to become computationally intractable. Quantum field theory renormalization failure would become complete when the infinite quantities that appear in quantum calculations become so severe that no mathematical procedure can make them finite. Normally, these infinities can be absorbed into redefinitions of physical constants, but at the energy scales of light-speed travel, the infinities would become uncontrollable, causing quantum field theory itself to lose all predictive power and mathematical consistency. The concept of cosmic censorship catastrophic failure would occur as the formation of naked singularities around your spacecraft exposes the mathematical infinities of general relativity to the outside universe. These exposed singularities would create regions where physical quantities become infinite, potentially causing the breakdown of causality and the mathematical description of spacetime throughout large regions of the universe. If you made it this far, I am sure you will love this other video at the left side of the screen. This is why the speed of light is ridiculously slow. In this video, we go into details on why the speed of light is actually way too slow when it comes to the vast scale of the universe. See you there.